In this particular video, I asked 10 questions. After each question, kindly pause the video and try to answer. And again, after that, you compare your answer with my answer. Here I have given a mix of C and C++ questions. Now, the first question is, explain enum with suitable example. Okay, so enum allows us to create our own data type. For example, enum marital status. Here, marital status is a new data type. And single and married. Automatically, single gets a value 0 and married gets a value 1 by default. Always, so enumerator starts with 0. So integer values, single gets a value 0 and married gets a value 1. So here marital status is a new data type. So it allows, enum allows us to invent own data type and define what values the variable of this data type can take. By default, single takes 0 and married takes 1. If you want to change the value, you can do like this: single equal to 100 and married equal to 200. By chance, you have not given married equal to 200, just single equal to 100 you have given. Think of the scenario: single equal to 100 and just you have given like this, married. Then in this particular case, married will get the value 101, 101. Married will get a value 101. So enum marital status person 1, person 2. So here we are declaring variable person 1 and person 2 of data type marital status. So marital status is the data type, like how we have built-in data types like int, float, char, double. Marital status is a user-defined data type. So here variables are like person 1, person 2. Typedef. Explain typedef. So typedef provides a short and meaningful way to call a data type. For example, typedef unsigned long int. Now, instead of using like unsigned long int, you can use two words. You can use two words. So two words, variable 1, variable 2. So our two words A comma B. So two words means unsigned long int. The meaning of two words is unsigned long int. Struct, we will see one more example, struct employee. Now, typedef struct employee emp. Instead of struct employee, we can use like emp. Now, emp e1 comma e2. So here, memory will be allocated to e1 to store name, that is 30 compartments, and age, that is around 4 bytes, and basic salary. And again, to store E2 also, memory will be allocated like that, E2. So total here 30 bytes, 30 plus 4 plus 4. So 38 bytes for E1 and 38 bytes for E2. 38 bytes for E1 and 38 bytes for E2. What I mean by macro expansion, it is also called symbolic constant. Here upper, so anything with hash define. Okay, so upper. See, normally symbolic constants, we give it in uppercase. So that is very important, uppercase. So wherever upper is there, it will be replaced with 25. So in this program, wherever upper is there, it will be replaced with 25. The advantage of macro expansion or symbolic constant is, think of the scenario, we have used 25 in 100 different places. Tomorrow, client will come and ask you to change 25 to 26. You need to go to 100 places and do the change. By chance, you have done the change in 99 places and you have forgotten to do the change in one place. That will lead to logical error. And logical errors are the most dangerous errors actually, because nobody will be there to warn you. Syntax error, at least compiler will warn, but logical error, nobody will warn. So this, by using macro expansion or symbolic constant, we can eliminate logical errors very easily. No need to go to 100 places and do the change. Only in one place you need to do the change. Here, upper 26, you need to change 25 to 26. Again, compile it, and then in all other places, 25 will be replaced with 26. So macros with arguments. Explain macros with arguments. So macros are almost similar to functions, but only difference is in the case of function, we write function definition and we call the function. The control will go to function definition and execute all the statements of the function definition. Again, come back it and again it comes back to the calling function. So in the case of function, there will be two things. One is calling function, another one is called function. So called function is actually the function definition. So control will go from calling function to the called function, and once it completes the execution of the called function, again the control will come back to calling function. But in the case of macro, the control will not go in search of function definition. Wherever the function call is there, it will be replaced with the statements function definition. Here the example hash define area of x 3.14 into x into x. You should be very careful here. After area, there should not be any space here. So it should be like this, area of x. You should not give space actually after area. So if you give like this, it's not correct. Area, so don't give like this. So don't give space here. It should be area of x without space. Now float R1, memory will be allocated to R1, A equal to area of R1. So this particular statement will be replaced like 3.14 into R1 into R1. So the advantage of macros, it executes the program in a faster manner compared to functions. But only drawback with macros are suitable if the function definition is very small. Number of statements are like this 3.14 into x into x. If more number of lines are there as a part of function definition, then macros are not advisable, because if you call macro in 100 places, so in all the 100 places, that function call will be replaced with function definition. So the size of the source code will increase. So it is always, there is a trade-off between macro and a function. So if client is not bothered, if client is not worrying about space and he is worried about execution speed, go for macros. And if the client is not ready to give extra memory, so they are concerned about space, then better to go for functions. So functions will not take more space and little slower compared to macros. Arrow operator. Arrow operator is also called pointer to member access operator. It is very important. Arrow operator is also called pointer to member access operator. This operator is used when a pointer contains the address of the object. Very important. So pointer contains the address of the object of a particular class. We will see one example. So this particular program, it is very simple. Class simple, int A, int B. So by default, private. So even though I have not mentioned the access specifier, it considers it as private. I'm sorry. Public int C, int add of int comma int. This is declaration or prototype. I'm giving the definition outside the class. That's why scope resolution operator. So it informs that add function belongs to the class simple and it accepts two arguments are of type integer. and after performing some operation, it will return one integer. Now a equal to x, b equal to y, return a plus b. Okay, now int sum. So main is a non-member function. So int sum, memory will be allocated to sum. Clear screen clears the previous output. Simple E. Memory will be allocated to E to hold A, B, and C. So A and B are in private section, C is in the public section. So moral of the story, even a non-member function can access C because it is in public section. But a non-member function like main cannot access A and B because A and B are in the private section. Now sum equal to E dot add of 6 comma 5. So control will go in search of the function add, and while going it carries the value of 6 and 5. 6 will be copied to x and 5 will be copied to y. From x and y, they will be copied to a and b of the object E. So 6 will be copied to a and 5 will be copied to b. Return a plus b, that is 6 plus 5 is 11. That 11 will come and store it in sum. The 11 will come and store it in sum. Now, just we are printing sum. So 11 will be displayed onto the screen. E dot C equal to 10. See, here C is in the public section. That's why you can directly access from main. E dot C equal to 10. So 10 will come and sit here. But in the same way, how we have done E dot C equal to 10, we cannot do E dot A or E dot B. We cannot do. The reason is A and B are in the private section. If at all, if you want to access A and B, that should be with the help of member function only, that is add. Now, so E dot C, we are printing the value of E dot C, that is 10 will be printed. Now observe here, simple star E1 equal to ampersand E. So E1 is a pointer variable. E1 is a pointer variable. How did you come to know it's a pointer variable? Star is there and it holds the address of an object E. Think of the address of the object E is 3000. So 3000 will be stored in E1. 3000 will be stored in E1. Now, with the help of E1, I want to call the member function add. But E1 is not an object. E1 is holding the address of an object. So E1 is nothing but a pointer variable. With the help of a pointer variable, I want to access a member function. Then I should use arrow operator, pointer to member access operator. So observe the difference between E dot add and E1 arrow operator add. E dot add because E actually is an object, but E1 is a pointer variable which is holding the address of an object. So you have to use arrow operator. E1 arrow operator add of 5 comma 25. So control will go in search of the function add and 5 will be copied to x and 25 will copy to y, and from there 5 will be copied to a and 25 will copy to b and return a plus b. 25 plus 5, 30. That 30 will come and store it in sum. 30 will come and store it in sum. Now E1 arrow operator C. See, observe here, E1 is holding the address. So 3000 of C, so is 20. Now we are changing C to 20. We are changing C to 20. So print E1 of C. So we get 20 as the output. We get 20 as the output. So this pointer, very simple. Whenever we call any member function with the help of the object, the address of the object will be stored in this pointer automatically. I repeat, whenever we call any member function with the help of an object, the address of the object will be stored in this pointer automatically. Now let me trace this program. Simple E. So memory will be allocated to E to hold. So the private data member A, because I have not mentioned the access specifier, so it will be considered as private. It will be considered as private. So the address of E is, think of 2000. The address of E is 2000. E dot set data of 5. Now what will happen? So you are calling a member function set data with the help of an object E. So the address of the object E should be stored in this pointer. So this pointer is holding the address of the object E, that is 2000. Now E dot set data of 5. So 5 will go and store it in X. This arrow operator A equal to X. Why? Because we are accessing A with the help of this, but this is a pointer variable. So that's why we are using arrow operator. Arrow operator I discussed in the previous question. So whenever you're accessing a data member or a member function with the help of address, then use the arrow operator. If you are accessing a data member or a member function with the help of an object, then use dot operator. So this of A equal to X, this means 2000. 2000 of A equal to X means 5 will be stored here. So value of A, this of A means 2000 of A, that is 5 will be displayed, and the address of the object E, so equal to this. What is there in this? 2000. So 2000 will be displayed. Anyhow, the address of the object is 2000 in this particular case. What do you mean by inline function? Inline function is very similar to macro. So it is very similar to macro. Inline function is in C++, macro is in C. Now inline, int large, int x, int b. So it is to find out larger of two numbers. If a greater than b, return a, else return b. Now int x, y, z, memory will be allocated to x, memory will be allocated to y, and memory will be allocated to z. Enter two values. I enter 10 and 20. 10 will go to x and 20 will go to y. See, okay, z equal to large of x comma y. Here in this particular place, large of x comma y, that will be replaced with this. If a greater than b, return a, else return b. So in our case, so y is, that is 20 is greater than 10. So what will happen? So 20 will be returned, the 20 will be stored in z. So C out largest Z, that is 20 will be printed. 20 will be printed onto the screen. What is constructor? Constructor is a special member function in C++ whose name is same as that of the class name. And it is the only way to initialize the data member of an object. So when object of the class gets created, it is called special member function with only restriction that it cannot return a value. Why it is called special member function? Because it is having the same name as that of the class. We will discuss one simple program. Class A, private int A, so data member, public int get void A. So here, this is a constructor. How did you come to know it's a constructor? It is having same name as that of the class name. Class name is A and the name of the constructor is A. So you can come to the conclusion this is a constructor. Constructor will always have the name of the class. Now we are writing the definition of this get function outside the class. That's why we are using scope resolution operator. Get is a member function belongs to the class A. Get is a member function belongs to the class A. And after performing some operation, it returns integer value, return A. So int main A1. Memory will be allocated to A1 to store A. Cout A1 dot get. So this should be A1 dot get. Now before this, when the moment when you create an object A1, automatically constructor will be called and 5 will be assigned. 5 will be assigned to A, or we can say A is initialized with 5. A is initialized with 5. So the moment when you create an object, so data members will be initialized with the help of the constructor, So if you write like cout A1 dot get, this is not A dot get, A1 dot get because the object is A1. So you get the output as 5. What do you mean by reference variable in C++? Reference variable means aliasing. For example, int A. So memory allocated to A. You want to give another name to A. Somehow you don't like A. Int ampersand P equal to A. So P is another name given to A. See now, observe the syntax here. So ampersand comes at the left hand side. Then it is called reference variable. Then it is called reference variable. If ampersand sign comes at the right hand side, then it is called address of operator. Then it is called address of operator. Now here it is a reference variable. Here it is a reference variable. It is also called aliasing. Is it possible to pass default arguments to the function in C++? Explain with suitable example. Default argument means default values to the arguments. Okay. So it is default values to arguments. So int x here in the declaration, int multiply, int a, int b, int c equal to 5. This is perfectly correct. But think of, you cannot give it value to a without giving value to b. You cannot give it to b without giving it to c. Moral of the story, always default values should be, okay, so assigned right to left, right to left. So you have given to c, so you can give it to b, but you cannot give it to A without giving it to B. Always it should be from right to left. Always it should be from right to left. And the default values should be given in the function declaration itself, not in the function definition. So it should be given in the function declaration. Now observe here, int x comma y, memory will be allocated to x, memory will be allocated to y, x equal to multiply 2 comma 3 comma 6. I am passing 3 arguments. So 2 will be copied to A, 3 will be copied to B, and 6 will be copied to C. Now it will not consider the default value. Okay, default value it will not consider. Now second time you are passing 2 arguments. Multiply 1 comma 10. 1 will be copied to A, 10 will be copied to B, and what will be there in C? So 5 will be copied to C. So it will take the default value. So if you only pass the argument, it will ignore the default value. If you do not pass the argument, it will consider the default value. It will consider the default value. Thank you.